So we have to begin graphing the next three: cosecant, secant, and cotangent. So to do this, we need to remember which functions they are paired with. So if we want to graph the cosecant of x, we have to remember that that is the reciprocal of sine. Okay, so to help us here, the plane cosecant, we need to be able to graph the regular sine key points. So if you remember, the period of sine is 2 pi. That means the halfway point is pi. And sine starts at the origin, goes up the amplitude, goes back, goes down the amplitude, -1, and it returns at 2 pi. Okay? So here I'm going to draw in a small red line. This is what our normal sine would look like. Now we have to think about what the cosecant would then look like. One thing that's really important here is, because sine is in the basement of our fraction, if sine is ever 0, that is going to be an undefined point. That's going to be a vertical asymptote. And so, let me highlight here, we have one place where sine is 0, two places where sine is 0. We have it actually every single pi. So those are vertical asymptotes. If you're doing a graph on paper, you would want to put a dotted line going through these highlights, okay, whenever the graph touches 0. Alright, and so the other thing that happens is that we will have a shape that will start from positive infinity, come down, hit our normal amplitude from the sine, and then kind of go up like this. So that means back here, when sine is negative, we are going to have something similar, kind of like this. Now the reason is because you're dividing by the height of sine. When the height of sine is 1 right here, 1 divided by 1 is 1, so they're the same. As sine gets smaller, you're dividing by a smaller and smaller number. And if you remember, dividing by a number that's approaching 0, that means the division is going to get larger and larger. Okay, so the key here is that you graph the sine or the cosine to find your key points and your asymptotes, and then you draw the up and down arcs like this. Okay, so if we were to continue this, cosecant would continue this pattern, and we would have, right here would be 2 periods. The idea is that you need to figure out what is the total width, where if you added that much, you would return to where you are. So it is still 2 pi. So like sine, cosine, cosecant, and secant will have a period of 2 pi. Cotangent and tangent, those are the guys that have the period that is actually just a pi. Okay, so we're going to do an example now of one with an ugly transformation situation. So we're going to do alright. So to do this, we're first going to think about what the matching function would be. Since it's secant, we're going to look at all the same transformations, but with cosine. Okay, we're going to graph that here, and I'm actually going to do 2 graphs to help us here. The first graph, I am not going to do any horizontal or vertical shifts. So the first graph, I'm going to worry only about my A and my period. Then after that, we will be able to shift right 1, as this says, and up 3. It might make this easier. So the cosine here will have a period 2 pi divided by b, and in this case b is your pi. So we will divide, and we will get 2. that means I will have a full wave. Whoops. After just 2 units, not 2 pi, just 2. So that gets rid of all the pi's for our axis. Okay. And now the amplitude is 2, so when we have a graph, a height, we will be 2 up. When we have a depth, our lowest point will be -2. And cosine will start at the amplitude. Halfway at 0.5, it will be halfway. At 1, it will be at the bottom. So our cosine normally looks like this if it has an amplitude of 2 and the period change so that the period is 2. Now for this graph here, I'm going to extend it a little more. So this guy right here is 3. Because just like before, I'm going to highlight the parts where we have a 0 on the graph. That will be right here, and right here. Okay, now those are going to be our asymptotes. So on your paper, you would draw dotted lines there and there. And then if you remember the last graph, to figure out the shape of the other one, we just will draw it down and connect it here. Now I can do this because I'm on a computer and can erase my strokes, so I can just erase this and this. Now those key points are still important, but if you take away the cosine, this is what your secant should look like. So what used to be a cosine, that is just our guide to figure out where should we put the secant line. So this guy repeats on forever. Alright, so now we're going to do some shifts here. The -1 means 1 right, it's the opposite inside, and then 3 outside is up 3. So what I can do here is I can take these key points and the asymptotes, and I can just shift them. So since this asymptote is back at 0.5, I would shift that to 1.5, right? Alright, so on my graph here, let me write 1, 2, 3. Should probably put a hash there instead of just the 2. And I want you to notice here, we have a shift to the right of 1. Now, if I take my asymptote and I shift it to the right 1, in this case, the asymptotes will land exactly where they were, because we're just going to be shifting the asymptotes 1 over. And so in this case, and it won't happen this way every time, the asymptotes are still going to remain at every half unit, like this. Okay, so that takes care of our shift right. Now, for our shift up, everything is shifted up 3. So what used to be a -2 is now going to shift up to 1. And all of that graph will shift up like this as well. So that will be 1 there. Now for the next one here, this is at 2, so that's going to be shifted up to 5. Let's just mark this 5. And so what used to be over 2 up 2 will now be over 2 up 5. And we could repeat this on as far as we need to. Okay, so I recommend this way. This might be the easiest way, especially with secant and cosecant. Draw your guiding sine or cosine, and then use those points to figure out your asymptotes, where 0, and then where your center is for these little arcs. And then when you're done, you can go over and translate the entire graph to make it work. Alright, so we still have to show you cotangent. And so let's just look at the parent function. And I think if you know what the parent function looks like, you can do transformations because it is almost identical to tangent. And remember that this is 1 over tangent of x. So to think about this, we will think of the regular tangent function. And we said yesterday that it has a period of pi. So we have these asymptotes, and we have the center point at 0, and then at pi over 4 and negative pi over 4 we were 1 and down 1, so we have those 3 key points. And then we have this wave. Not wave, this shape. Now if we continue this on here, this next asymptote would be pi above the last asymptote, because the period here is exactly pi. So pi plus pi and a half, that would be 3 pi over 2, and this would repeat. Okay. Now what we learned from secant and cosecant and so on is that when we're doing 1 over tangent, that tells us, the zeros tells us where our new asymptotes are going to be for cotangent. And so I highlighted there, but for cotangent, we will have an asymptote right on the y-axis, because that's where tangent was 0. The other place where tangent was 0 was at exactly pi. And if you follow this then, and you go backwards, you should have an asymptote at negative pi 2. Alright. Now the only thing to consider here, then, is that cotangent is when you flip your sines and your cosines. So if you're thinking about the tangent, and you're thinking of 1 over the tangent to get cosine, let me highlight an area here. If you look at this interval here, that is between 0 and pi over 2. That would be this place right here, halfway. In that place, tangent is positive. So for the cotangent, it's actually going to be the opposite, but positive. And then we will put a 0 right where there is an undefined on the tangent. So it's kind of the opposite. And then if we highlight the other side, tangent is negative. So if I did 1 over tangent, it should be negative on that side as well. But it's going to be opposite, so it kind of looks like this. The moral of this story is that the cotangent should be the opposite of the tangent, meaning it should be flipped over the x-axis. And so your cotangent will look like this. So if you were able to do tangent transformations, you should be able to do cotangent transformations. Just remember that the period is still pi, but the period is shifted over pi over 2 from what the tangent was. So while we had pi centered around this 0 right here, now we have a pi period centered around pi over 2.